For today's video, we will be talking about radical halogenation of alkanes. So for example, if we had this structure in this case, and it had this is an alkane, and this was reacting with a halogen element, so let's say bromine in this case, we would use bromine most because it is more selective than the other halogen elements, okay? And so for this, it would either have the reagent heat, right? Or you can actually react this with UV light. Both are the same thing if both are going to give you the same product, so it doesn't matter which one you use. So for this, how we determine this, we see that there's a hydrogen here, and all we do with this hydrogen is remove it and add the bromine to it. So in this case, we would add this on this carbon. We would add on this carbon because that carbon is tertiary, and tertiary is the most stable because everything else, all the other carbons that we see, they are secondary because they're connected to only two carbons. So in this case, we could actually draw it bromine like this on here. And this is our final product for this problem. Again, as you can see, bromine will go on the carbon that has the most amount of substituents. So tertiary is the most in this case. Also, there is no chiral center, so in this problem, but watch out for stereochemistry. So let's do another example here. We had this structure, and this is reacting with a bromine, two bromines, and let's say for this case we use heat. The same thing as UV light. Okay. So in this case we see that they're all secondary. So this is 5 carbons, but they're all secondary carbons. So in this case we actually have an option. Well, not an option, but we would have more than 2 products. So as you can see, we can put the the bromine here, but also we can put the bromine here. So if we redrew the molecule, we put it like this, okay? But also this carbon right here is a chiral center, so stereochemistry applies. We will get a racemic mixture, half wedge and half dash, like this, okay? And then plus the other one, where we can put the carbon over here on the third carbon. So this will give us something like this. The last one is not a chiral center because we have symmetry. If we cut it in half, we see that the left side and the right side look alike. So that means there is no chiral center here. So we would have 3 products in this case, okay? And some may say, why not add the bromine here? If we do that, it would look like this, right? Basically, this is the same thing as these two, right? These are the same thing, so no need to do that. In this case, we would have 3 products. Let's do another example. Now, in this case, instead of having 5 carbons, we would have 6. This is reacting with bromine 2 over UV light, right? So in this case, the same thing. We had to add the bromine on the carbon that has the most amount of substituents. In this case, they all are secondary carbons, so that it doesn't matter where you add it to. So in this case, we're going to add it again on the second carbon and on the third carbon. So let's do that. When we do that, we see that there's actually a racemic mixture here. That's a chiral center, so half wedge and half dash. Also, we can add it on the third carbon here, okay? As a matter of fact, this and adding on here is actually the same thing because we have 6 carbons, so they're both on the third carbon. So we're going to add the other one. It's also a chiral center, so there's a racemic mixture. And then we add the dash, okay? Bromine. Don't focus too much on 4 products. For the most part, you'll have only probably 2 maximum in your class. So but this is the answer for this problem. Let's do another example here. We had this structure, and this is reacting with bromine 2, let's say with heat, okay? UV light and heat will give you the same product, okay? So in this case, we see that there's a hydrogen here, and then there's a hydrogen here. That means that this carbon over here is chiral. Not chiral, but it's secondary. But this carbon over here has 4 carbons connected to it, so 4 bonds, right? we said that we add the bromine to the carbon that has the most amount of substituents. But we need a hydrogen to remove to add the bromine. This carbon over here has 0 hydrogens. So we can't just remove a carbon and add a bromine, because if we did that, it'll change the molecule. But also, of just adding the bromine on here will give carbon 5 bonds, and we cannot do that. So in this case, what we do is that we have to add it on the secondary, okay? So we would just remove the hydrogen and add the carbon, add the bromine. So we would get something like this. This is also a chiral center, so stereochemistry applies. So a racemic mixture, 50% wedge and 50% dash. Bromine like that. And this is our 2 answers, 2 products for this question. Let's do another example. We have this structure. Okay. And this is reacting with bromine 2 and let's say UV light. Okay. So in this case, we see that there is a tertiary and secondary. We would add on the tertiary because there's an extra hydrogen here, right? And it's more stable, so we remove the hydrogen, and all we do now is just add the bromine to it on that. So for our final product, we would get something like this. And this is our final product. There is no chiral center. It's not racemic because this carbon over here, we see that there is 2 methyl groups over here. So chiral center needs 4 different bonds. So in this case, that is the answer for this. Let's do one more example for the products. We had this structure. Something like this. And this is reacting with bromine as well. For the most part, you would always see bromine reacting with this. Chlorine can work as well, but chlorine just a little bit trickier. All we do now is that we redraw the molecule. Okay. You see that this carbon is most substituted, but it doesn't have any hydrogens to take away. And that is not tertiary, because tertiary is the most stable, but it is, you can only do it maximum 2 tertiary. So in this case, this is tertiary over here, has the extra hydrogen here. So we can remove that and add the bromine to it. So in this case, we'd have this. We would have this, the methyl group, and then we have the Br. But also, this is a chiral center, so we must make it chiral. Let's put a dash on the methyl group, and then add the wedge on the bromine, and plus the other half of it. And this is our final product. We have 2 products for this question. So now when doing this mechanism for this products, the structure of the equations, all right. So the first thing we have is a 3-step problem. The first step is initiation, where the formation of radicals comes in. And so in this step, for example, if we had a drawing X, right? X and X is connected, and it makes 2 radicals on the product side, right? 2 radicals on the right side. So for this case, it would happen something like this: 1 arrow, because we're moving 1 electron instead of having a full arrow, which we would move 2 electrons, right? So the next step that we have after initiation, after forming 2 radicals, is called the propagation step. The propagation step is that where we have 1 radical on 1 element and it moves, or compound, and it moves to the next. So for example, we have X plus Y, X radical plus Y, right? This would form X not having the radical, but now Y would have the radical. So we have 1 radical on the reactant side and 1 radical on the product side. And finally, our last step, it is termination. And this step is that where we would have the reaction come to an end. So in this case, all you would do is just find 2 radicals. So let's start with what we had before, the initiation step. And this would be like this. All they would do is actually come together to form a single bond like this. So it would have 2 radicals in the reactant side and 0 on the product side. And so this is the 3 steps of the mechanism. one thing to remember is that if we have a single bond, right, this is equal to 2 electrons, right? 2 electrons is also equal to 1 lone pair, right? But now for radicals, we are moving 1 electron, okay? So in this case, you can think of it as something like this, right? We have 2 dots, just 2 electrons. And so all we're doing is just moving 1 electron to each compound element, right? So something like this. This is radicals right here, just 1 electron. So it's an unpaired lone pair. So let's start with this problem, the structure on this. And this is undergoing a reaction of Br2, and let's say in this case, put like the heat. So in this case, we have to draw the mechanism for it. So let's draw a line right here. So the mechanism, as we said, the first step was called initiation. So in this step, all we want to do is that to have a 2 radicals form during the product side. So initiation is the first step, and all we do now is actually bring down the reagents, the Br2. So in this case, let's start with Br2, right? And from here, we just move 1 arrow to each half arrow like this. Half arrow to here, and a half arrow to here, and then now we have formed 2 radicals. So now we are done with the initiation step. We have formed the 2 radicals that we want on the product side. The next step will be the propagation step. So on this step, we're actually going to use one of the BRs. So let's just use this. So BR with this radical. Okay. Don't forget, actually, bromine has 3 other lone pairs connected to it. So just keep that in mind. So it's connected to BR, right? Actually, instead of writing this, we first actually would draw the structure. So let's draw the structure. And let's pick this carbon for the bromine. So something like this. And now we have connected to the other carbon. Okay. CH3, and then we have CH3. You can see that the last carbon over here, I actually drew out all the hydrogens. This is because we're going to react it. Now we bring in the Br with the radical. Okay, remember it has 3 lone pairs. So with this radical, we want to form a bond, right? We want to form a bond with the hydrogen, and we want to remove that hydrogen from this carbon. So in this case, we do a half arrow here, and then a half arrow here with this bond. And then the other half arrow would go back on the carbon. So like this. Like this, half arrow. So this reaction will undergo something like this. CH3. And this carbon only has 2 hydrogens. Oops, not this carbon, but this carbon has 2 hydrogens, but now it has the radical plus the HBr that we have formed. Okay, our first step right here. Now again, from this step, would actually would react this structure if we had taken it right here. This we're actually going to redraw it over here on the bottom. So CH3, C, and then CH3, CH3. Okay, don't worry about the HBr. It's not going to affect our product and whatnot. So it has 1 hydrogen and it has the other hydrogen here with the radical. Now from here, okay, we would actually form it out with the 2 BRs that we have in our right here, this step right here. So we would bring this down, BR like this with the other BR. We have 3 lone pairs. Okay, start with the double bond or the single bond. Half arrow to form with that radical. Whenever you see the radical, we have to form it a bond, and the form back over here on here, the half arrow. Okay, so this will give us a result of CH3, C, CH3, redraw the structure, okay, CH3. Now this is connected with the carbon. Also connect now to the bromine. Let's put bromine right here and let's add the other hydrogen on it. Okay, so we remove one hydrogen and we have added the bromine. So the first step on the propagation, this step right here, this was called something called hydrogen abstraction, right? Or remove the hydrogen. So this is called hydrogen abstraction. The bottom portion of it, this reaction over here, this was called halogen abstraction. Or remove the we added the bromine onto that structure. Abstraction. Actually, on the top, in the initiation step, right here, this was called, well, not this, but this right here was actually called homolytic cleavage, meaning they both broke down in half arrow to form a radical, right? Homolytic cleavage. So they used two half arrows to break the bond and have a radical. Okay, and as a matter of fact, the halogen and the hydrogen abstraction, it would be actually this step over here. This for the hydrogen, and then the halogen would be this step over here. Okay, so now finally we come to our last step, and this would be called termination. The easiest step. All you do is look at your the work you have done, pick random radicals from the problem. So in this case, for simplicity, I would use the two bromines that have the radical, right? They both have one radical, and all they do now is they come in to form a bond, and this bond will be something like this, and this reaction over here is called coupling. It's called coupling, and this is the reaction for it. Termination, you can actually go further more, but just running one would be enough. All you do is just bring the reaction to an end. Let's do another example. If we had this structure, okay, and this is reacting with bromine 2, right? With this time, let's say UV light. Same thing with the heat. They'll give you the same product. So we know what the product looks like in this case. Let's draw the mechanism for this. So the first step that we do is the initiation step. Okay, in this step, again, we use our first reagent, will be the Br2. So from here, we do this, the bond, right, and this will form, say, homolytic cleavage. So we use two half arrows to form two radicals. Okay, so radical here plus radical here. And don't forget, bromine has 3 lone pairs always. They still have 3 lone pairs in this case. Okay. Okay, like this. Next step we have is the propagation. Okay, so the initiation step was done in this case. Okay, propagation step in this case. All we do now, bring it down the structure, and then now use one of the radicals. So Br the radical, both the same thing. In this case, what we do is we see that we have this carbon over here that is tertiary, so it's the most stable. It has the hydrogen that we want because we want hydrogen abstraction. So we would form the bond with it. So something like this, forming something like this. While this bond will go back on that carbon. Okay, so like this on that carbon, and this will give us a product of this. Having that out, this carbon has the radical now, and now it's added with the HBr. Okay. Don't worry about too much about the HBr. We're not using it in this case. So redraw the molecule, our new molecule with the radical. This carbon over here. Now bring on the Br bonded together. So now in this step, all we do now is just start from a single bond and go form a bond with the radical. Really technically with that carbon that has the radical, and the other side will go like this, so half arrow on the other bromine. And so we get a reaction that will have forming a product of bromine on here. Okay, that is what we want, and also the other bromine by itself with 3 lone pairs in the radical. Okay. And that is how we got the answer, right? For our products right here, propagation step. So again, we see the homolytic cleavage, hydrogen abstraction over here, and then we see halogen abstraction over here. Finally, we do our final step, which is termination. So in this step, all you do is just pick any radicals from the problem work we have shown and bring it to an end. So I'm just going to pick the same one, so like this, plus the other bromine with the radical, form a bond connecting to bring the radical to an end. So like this. Other ones you can do is maybe you can have this, our radical structure with the radical, plus the bromine radical, and they come and form a bond, right? Half arrow, like this, and so you would have like this. This wasn't our propagation step, so you'd have an arrow like this, and this is called coupling, where they come together to form a bond. So like this. So any of these for termination can work.